Audio. Oh, are we live? Let me open up chat. Uh, YouTube chat. Yeah, nice. Let's see. Hey, let's go. Hello, hello. Okay, the audio is coming from now. If I switch. Hello. Okay. Looks like we have audio now. Uh, what's up, chat? Today, this is another episode of the doing stuff that no one really cares about, but I do. Anyways, so today we will be looking at a simple 3D render engine in pure Java. So I found out this blog post that basically, explains what the 3D render engine is and what we are actually trying to do. I think today we won't be looking into coding as much as what we'll try to do is just understand the 3D aspects of it, the maths behind it, and stuff like that. So, because like you can code this up easy, but I think understanding how it works is the main sort of the secret sauce, if you will. So, what I'm going to attempt to do is go through the blog post, and then we can, sort of, I guess, understand the stream or understand the maths behind it, if that makes sense. I will link the blog post as well because it's a good blog post as far as what I've read. I will post it on YouTube in the comment section. Hold on. Give my give my potato PC some time. Yeah. Okay. Let's open my own stream. Okay. We had like a brief echo going on, but yeah. Okay. What? I can't open panel from here. Some stuff, dude. What the hell? Fine. Well, I'll just update the description, I guess. This stream, we will be making a 3D render engine in Java. Article link. There we go. We added it, so now it should be visible in the chat as well. Looks like the changes are saved. Nice. Okay, I think enough chit chatting for now. Enough chit chatting, yip yapping. Let's start actually doing the reading now. So I will just change to the screen. Let me find out dark mode over here. We have the reader. No, I wanted the extension. Yeah, the dark reader one. Okay, it's on, but what the hell? It is on. Okay, yeah, there we go. Actually, never mind. I think the reader was better than this, but okay, whatever. I'm just going to switch to the reader regardless. I think, whoops. Where is extensions? It's like I am blind. Okay, cool. Yeah, so how to create your own simple 3D render engine in pure Java. So you'll sort of read through this blog post. It says it's 21 to 26 minutes. Let's see. 3D render. Okay, by the way, this is the link. It's in the description. Read it, give it a read. It's a really good blog post, at least to the point where I have read it. I found it pretty clear. Anyways, so yeah, 3D render engines that are nowadays used in games and multimedia production are really complex and they produce stunning results. I mean, yeah, no shit. Have you looked at the latest GTA 6, GTA 6 visuals? I mean, they're crazy. Look at this one. I know that this is within fair use, which is why I can comment on it. But okay, now this is GTA 5, but if you go to the GTA 6 trailers and stuff, and you've seen it, right? This just look at how realistic this looks. And this is sort of this type of uh, generating is what basically 3D render engines do, right? You have a 2D screen and it gives you the illusion using maths and a lot of tricks that you are actually seeing something that's 3D, although you are viewing it on a two-dimensional surface. I hope that makes sense. So, like, I have this bottle, and this bottle is 3D, but you are viewing it on a 2D screen, right? So you are not directly seeing it, you're seeing the projected form of the 3D bottle on your screen. I feel like that complicated it way too much, but yeah, it is what it is. Many developers think that building even the simplest 3D application from scratch requires inhuman knowledge, but thankfully this isn't the case. Yeah, this is why I like this article. Why would you want to build a 3D engine? It will help understand how real modern engines do their black magic. Also, yeah. So what this basically like, sums up is, even though you don't really require 3D engines in your everyday life or whatever, I think I agree with the writer or author somewhere that it's a good to have thing, right? And also they say that this will run almost anywhere and fit into 50 KB, run almost anywhere because it's Java and Java is basically running everywhere, right? Code examples will be in Java, but ideas explained can be applied to any language of your choice for your convenience. I will be following along with small interactive JavaScript demos right here in the post. Cool. Right, so we want at least something on the screen with our rendered image and two sliders to adjust the rotation. Okay. Uh, so they basically have created this. Oh, okay, it's just a screenshot. Okay, fine. So, so they basically make a GUI wrapper. Okay, I have some experience of doing 3D work in C++ on OpenGL. So I think what they are trying to do is like define a window and allocate it some sort of fixed dimensions. Yeah, so JFrame, new JFrame container. So they are defining a frame. Basically, the way we define our body, right, on C on an HTML page, where everything we want is sort of mostly on the body. Again, mostly in the body tag, right? Because the body tag sort of is responsible for reserving space for the components within it. So this is how I think we are trying to sort of do this. Then the resulting window should, okay, this is just the window. Now let's add some essential model classes. So they basically want to create vertices and triangles. Okay, interesting. So we are making a triangle now using three vertices. Yeah, that's fine. Oh yeah, this is important. Y means movement up and down on screen. Z will be depth and so is. So let's go to Obsidian. Oh, by the way, I switched up the theme again. Last time I think on stream I was complaining about hide, so I tried. I switched back to ML for W now. So let's see how this goes. Let's open a new Excalibur drawing. Right. Uh, let's rename it to also we could very easily make this in Java, Golang as well. So I mean, I think we should probably do that. Huh. Yeah. You know what? I think making an executive decision, I might just make this in Golang since Prateek is not here. So I mean, okay. So Prateek specializes or has more knowledge of Java than he has for Golang, which is why we decided that okay, we'll do the first two projects in Golang, the next two we'll do in Java, and some stuff along that. But since Pratik is not here, we can easily make this a Golang project. Although he's probably not going to be too pleased with that. Anyways, what I was trying to explain is we have the coordinate system, right, for this thing, screens. So it literally, or it actually starts from this point. So if we go here, we do 0, comma 0. So this is actually the origin for every sort of rendering scenario. Why is that? Because this corner was the chosen one, I guess. Even I don't really have like a good explanation for it, but I would say it probably was like a convention that was followed. Not really sure why, but yeah. So origin is here, and this is the y-axis, and this is the x-axis. So x-axis is pretty much the same, right? You go more means more to the right, but y-axis is inverted. In y-axis, more means more below. So if I take your standard HD display, right? I think what's the SD display is like 1920 times 1080 is I think what is yeah, it's 1920 times 1080. So what this means is that your screen is 1920 pixels wide. So the farthest x-axis on your screen will be 1920, or actually one less. It will be 1919, and it will be, and here it will be 1079, right? Considering the first point as well here. So you have all of these coordinate points to play with. So yeah, that's how that works. Again, this is like an abstraction. Java allows you to be flexible. I mean, it should. At least C++ allows you to be flexible. So does Python. I've actually done uh, this sort of frame-based, whatever you want to call it, simple UI layouts in Python as well using tkinter and this thing PyQt. Also, so yeah, whatever. What I want to get across is we have this coordinate system for the traditional screens, and this is what we are following. This is why, okay, why I'm emphasizing it is because I want to get this clear. You know, when someone is first time looking at this stuff, it really twists your perception. So every time we look at this is minus 100, x, but this is minus 100y, which means it will be below and to the left. Also, they probably have like an assumed center for this or something. We'll see how this works. Currently, not really focused on the code or replicating the code. Resulting shape is centered at origin, which is quite convenient here. So, okay, they applied some translation. So it looks like it's like a code walkthrough. I'll just have to read this. Do you want me to read it out loud? I think that's pointless. Right, we create four triangles and add them to a list. So this is one, this is two, this is three, and the one on top is four. Right. Also, I think what's noticeable is when you are how do you say the sides are shifting, which is like an illusion of sorts, and it's been created by having like different colors. So they have matrices. I'm trying to find anything, any pictures or such that will give me like a visual hint of the progress. Let's remove the reader. Let's check. Yeah, so okay, that's the square. Oh, right. So this looks like a square, but if I tilt it, what we are doing is we are just increasing and decreasing the size of, and I think we can do, okay, looks like this is not set right now. That is cool. So okay, these snippets they've done in JavaScript. This is cool. Yeah, so this is like the final sort of result that they have created. If I turn this really at the right speed, you can actually see. So it's actually an illusion. It's not. Also, this sort of breaks my mind. The fact that each and every physics, or not physics, but this 3D render engine actually does this. That's crazy. So a lot of math. It was just a simple thing, and now I think he's colored it. Yeah, damn. Also, look at the way it's been colored too. If so, red is behind now, and to give that impression, we are not showing the color red. Now, the color red is in front, right? Um, uh, I could watch this all day, actually. This is one of those things. Yeah, I could literally keep watching for the entire day and never get tired. This is not healthy. But yeah, this is like the end goal. They make like a 3D ball No, sorry, I'm a bit sleepy. So, okay, damn, this is crazy. Oh, also they have some comments. This is crazy. Nice. People, okay, maybe they are quite popular in that article. I'm not aware. I just came across this one and we decided to do it. So yeah, I think this one is worth doing, no? So okay, what I want to do now is I want to break this down into small steps so we can get like an actionable plan. Because I think in the beginning they just talk about the coordinate system and how they make this demo, and they have these formulae. Okay, so XZ rotation matrix, YZ and XZ. So this is all, I think, just a way to show things. Uh, New JFrame, Java X Swing, and AWT. This is for rendering the frame. Actually, I am a bit curious because I actually never really have done any front end in Java except this thing, servlets and stuff. We'll write week three, uh, 3D render engine. No, let's just say 3D engine. That sounds cooler. Yeah, 3D engine. Nice. Again, as per tradition, I mean, at this point, should we even make a different one or yeah, you know what? I'm just going to keep the same one. Anyways, all my all my homies forget to show up at these streams. All my homies probably out there, doing their enjoying their life. Anyways, so okay, we do know now that we are going to use this sort of a coordinate system. Now, what the person does is he basically sets sort of a frame. So frame dot set size and set visible true. Again, I don't want to clickbait people by saying, "Oh, it's in Java," and then not doing the Java thing. But yeah, let's J slider, heading slider. Hmm. Yeah, I don't really mean. Oh no. import it's java x dot string dot star. And then java dot awt, no? Okay. Let's just see demo and then um it's jframe new jframe. Okay. Jframe is a type. The hell? I don't know anything about. I'm just going to copy this one. Let's see what happens. I'm not going to pretend that I know Java when I don't. I don't know Java, guys. And that is fine. I'll learn it. Uh, Java, or do you say G? Let's just check. We do have OpenJDK. Okay, cool. Mean the Java dash O. Oh, okay. So it does compile. Okay. Uh, I think this gives like a fair idea of how it is showing up. So here, yeah. So you have this slider and this slider. Wait, hold on. I'll stop my camera for this. Yeah. Okay. So it's two sliders that are showing up, and we have this screen that's showing up. Cool. That's what we wanted to do. Let's see if there is a way to do this in Golang. How to GUI in no and graphics. Do people even use Golang for graphics? I don't know. Okay, looks like graphics API. Okay, looks like you need libraries. Yeah, I'm not going to do that. We will just have to learn, yeah, how to do this. So I think let's stop the coding part for now. I'll set everything up for now. Yeah. Let's just say initial. There's no need for comment. Okay. Yeah. hmm Let's see Java AWT abstract window toolkit. Okay. Let's look at Oracle's documentation. Docs.oracle. There you go. Open. Actually, we want for OpenJDK. I don't even know why Oracle has licensing for Java. It's literally free. AWT has a very old code base. Okay, hold on. Let me sip some dihydrogen monoxide. Also, this is burning my eyes, dude. But since this is a website literally written in HTML, CSS, we are good. We are in good hands. Oh wait, are we? Yeah, okay, we are building and rebuilding. Okay, the abstracting window toolkit group. Okay, parts of the old code are intermingled with other low-level parts of JDK such as 2D, IA10, and input methods. Majority of AWT code consists of the directories shown below. Okay, contains public API thoroughly specified in here. Okay, we can go through that. Contains API that is more volatile, and I think we don't use this one. We just use Java AWT, right? In main dot here. We don't use Sun. We don't use that package at all. So same here, contains low level implementation of AWT. We don't want this. Yeah. Okay. So SRC shared native Sun AWT. Most of the native code base is written in C and C++. Most of the code is platform specific and resides in the corresponding SRC Solaris or SRC Windows. Cool. Building and rebuilding. Okay. We are not doing that. I just wanted some documentation. Let's see here. Contributing. Oh, we can't contribute yet. Don't have that dog. We don't got that dog inside of us. Port haiku. What is this port? Uh oh, so memory model update, Loom, JDK. Okay, these are just projects. Okay, these are groups. Developers guide. Okay, let's see if we can find something here. Let's see. AWT API. Oh wait, what? Oh, this was the one that they mentioned. Oh, okay. The java.sun.com one. Yeah, it literally redirects to docs.oracle.com. Okay, cool. I guess that is crazy. Anyways, AWT packages. Okay, now. So this is the developer's guide, author, reviewer, committer, and stuff like that. Dude, this is crazy. This is this is OpenJDK, and they are agreeing to. Okay, no, this is not what we want to look into. This is some company level stuff. This, yeah, we just want to see how or where we can find documentation for AWT. But this is crazy, by the way. So even if you are like open source contributing, I think it's like you have to sign the OCA. Oracle is the steward of OpenJDK. If you haven't yet signed the Oracle contributor argument or agreement, please do so. Right? I mean, I don't know what the argument or the agreement is, so that's fine. Better not comment on it. Author, committer, reviewer. So there is nothing mentioned here. Okay, this is just like um, what to do and what not to do if you're doing an open source contribution. I want documentation. Okay. AWT packages, java.awt. Okay, yes, this is the one. So we use this for the entirety. We have java.awt more for the most part, no? Uh, God, I am being absolutely blinded with this. Okay, maybe the extension was actually doing its job. We just shut it down. I apologize. Yeah. Anyways, yeah. So I think yeah, we only use AWT and like some basic. Okay, I don't even think this is like. Uh, we just have a few separate. Um, this thing classes or are these classes? Yeah, these are functions. Public static color. This is like a class color, and then guys, I think the last time I did anything in Java was like when JDK 17 was a thing. Oh no, actually 20. Yeah, no, never mind. I think when I was doing app development, Java 20 was the new one. It's like it was like 2 years ago. I have not touched Java in like 2 years. So I am like really rusty. Oh, hey yo, Rat Mike X5 says your videos got me through my third year practical Lol. Thanks, man. They actually got me through my third year practical exams as well. If I'd never made those, I would probably not study as hard as I did. I just sandbag it probably. But coming back to this one, uh, okay, yeah. I mean, from whatever I see here, it's just one big file that they have done it in. It's not like a huge chunk of code as well, so that is fine. Okay, nice, cool. Uh, let's look at Java AWT. Whoa. Okay, this is massive. I think these are all the functions. Frame is a top level window with a title and border. So, okay, this is the class summary. This is the interface summary. Okay, I think we don't need to concern ourselves with interfaces for now because if imported everything. I don't know if we might need like color related something, but I don't see that as an interface. Yeah, I think this is like too simple for an interface. Yeah, color is a class. Encapsulate colors in the sRGB space. So yeah, yeah. Now let's just go by stuff one by one. Alpha composite implements basic alpha compositing rules. Blah blah blah. Root event class for AWT events. This is the class for AWT permissions. Okay. Canvas. Hmm. Checkbox. Okay, so they have like these basic sort of elements. Cursor, desktop dialog, event queue, file dialog. Okay, okay. I think this is doable because even C++ has something similar. So okay. So it's just I think the names are different. The names are different, and the functionality is the same. So first we need to render a frame, right? So we will render a frame first. Uh, a frame is a top level window with a title and border. The size of a frame includes any area designated for the border. The dimensions. Okay. Hmm. You know what? I was actually trying to think if I could be able to do the. I was probably thinking that I'd be able to do this. You write this code today itself. in the stream, but I don't think that's happening. Because the time is it's 8, right? So no. If I do it, I might be able to, but then it will take so much time. I don't want to do that. No, I don't want to strain myself because tomorrow is Monday and I have my normal day job to go to. Anyways, okay, fine. Let's skip this. I think I'll just try to understand the basic logic behind it, what what they are doing. Okay, so I think initially what they did was they just made a couple of sliders, slider to control vertical rotation and stuff like that, right? So we can write this as a step. I guess that's the most appropriate thing to do. Oh yeah, I can. Great. This has now I've been learning more about this Excalibur since I was educated by stream by one of our fellow members who was quite enlightening. Anyways, so we say draw uh, frame. Slider. This is like the first step. Also, I know it's not really conceptually related to the maths of this thing, but I think it's worth pointing out because I am starting at ground zero, which means that we are starting at ground zero. Okay, so they make the frame. They try to draw a triangle. So it's the easiest 3D shape. That's why the author has picked the tetrahedron. And then I think this tris.add just having a list of the array and they are adding the vertices. Is that we just create four triangles and add them to a list? Oh, okay. So uh, note how I applied translation before drawing all the triangles. This is done to put this to the center of our drawing area, right? So this is what I was talking about before, that 2D origin is located in the top left corner, so it's here. But they did some translation, so they did basically 100 translation, which is good. We know that, so we'll have to do that as well. Uh, where have they done the translation? They okay, because this is just 100. Hmm. Oh, okay. So they did the G2 translate get width, get height. Hmm. Interesting. So the center will always be in the middle of the screen, not at 100 by 100. Okay. Okay. So what we can do is uh, translate center um, to x by 2, y by 2. Let's okay. Why is it not? Uh, okay, cool. You draw like four. I think it's four. It's three, but if we need four. No, no, they do have four. So then what is the last one for, man? Because it's 100, 100. And yeah, you can do a lot of combinations with it. So create a class. I just say model for triangle and first then we'll do vertex and triangle. Then create four triangles and do the list. So this will form a tetrahedron. So I'll add it as a comment if I can. This is a tetrahedron. This makes okay. There we go. Create four triangles. Uh, Okay. Uh, dude, I just got bamboozled, guys, uh, because okay, we are doing all of this. So let's go through the steps again. We draw a frame with sliders. We translate center to x by 2 and y by 2 from the initial origin. We create a model for vertex and triangle. Create four triangles and add them to a list. To the list to a list. The tetrahedron. The issue is, okay, we are adding it to the this thing, whatever list, list or slice or whatever. But then, how are we going to make sure that the colors and all will stay? Because we are not. I don't think this is using any clipping algorithm. Uh, okay, let's read this. So because uh, okay, maybe it's the coordinate points are such that we form a triangle, but how do we make it move and how do we convince or trick our brains that it's actually 3D, right? So this is the transformations that we will do. To do the, okay, there are many possible ways to manipulate 3D points, but the most flexible one is matrix multiplication. The idea is to represent your points as a 3 times 1, a 3 by 1 vector, and transformation. Okay, yeah, so take your input vector A, this one, okay, and multiply it with transformation T to get vector B. Okay, okay. Also, I don't get this part, okay? So what they're saying is you can't describe all possible transformations using 3 by 3 matrices. Translation is off limits. You can achieve it with 4 by 4 matrices, effectively doing skew in 4D space. So what? So basically, he's saying that that to project a 3D, or I guess, okay, never mind. I think I'm overthinking it, but okay, so it looks like the number of dimensions you want to project on the 2D screen, that is the number of, or that is the order of matrices or the matrix that you want. So if you want a 3D, this thing, you would do a 3 by 3 matrix. So I think this is worth noting down. This mega tetrahedron. Here we go. Okay, so since for 3D shape for 3x3 transformation matrix with vertices. Hmm. Multiply. Hmm. Triangle. Right. Since the shape we want to. Okay. Ooh, fancy. Yeah, I guess you stop playing around. Ah, okay. Since you want to see the render shape is really cool. Um, why is it okay, dude? They have all of these rotation matrices, which is crazy. Like, how do you even have that many? Why do you have so many? So this output you would scale by point of two. Oh, so it's like a two. Oh, okay, this makes sense now. So let's see. So here to scale this whole thing by two, they did a two identity matrix 2 by 2 multiplication. Cool. Okay. So yeah, that I mean, okay. So that's how we can scale up and down stuff because that's exactly what we are doing, right? In this thing. If I go down, okay, probably the JavaScript won't be rendered in reader view, but basically the sliders, what we were doing was basically this um, increasing and decreasing size, so scaling up and scaling down. Any You can't describe correct. We talked about that. Any rotation in 3D space can be expressed as a combination of three primitive rotations. The rotation in XY plane, YZ, and XZ plane. Okay. I think yeah, this one also I should make the effort to understand. Let's see, mm, we have this. We have this plane. Then we have another plane. It's six or something. Yeah. Okay. Yes. Okay, and then we have the XY plane, the YZ plane, and another plane, the XZ plane, which will be perpendicular to all of these. Don't even draw it, man. Okay, this is like a little shabby. Needs some- So we have the three planes. I think I'll color it differently. Yep. Okay. I think we have the planes clearly mentioned. Mm, the Y, Z, and we have the X, Y. Right? We have all of these planes, and we want to, we can move, or we can move a point in any of these dimensions, a single vertex. So we can also rotate an object in these things, in this dimensional space. Okay, and then they have these rotation matrices. Also, what is theta? Damn, this is giving me maths trauma. I was not the best at math. I was like mid, like a little above mid maybe, but yeah, giving me giving me trauma again. Not in college though. College math doesn't even have numbers. College math is just engineering mathematics now. So I actually like college maths. We can just paste this here. Yeah. So we have all of these rotation matrices. If you need to first rotate in XY plane using T1, then rotate in YZ, you can simply multiply T1 with T2. Yeah, because matrix is like commutative or something. Basically, matrices, if you, it's like addition, except the sequence matters. No, never mind. Actually, yeah, the sequence probably does matter for this thing. But yeah, so what they're trying to say is if you want to rotate it in X, Y, and Y, Z, you can just rotate it in the X, Y, Y, Z plane together by multiplying these two matrices first. Yeah, exactly. So you pre-compute the matrix once and then use it in your pipeline. So we can pre-compute. So actually we should write this now. So we compute matrix transformations for number one. We wanted to x, y, y, z, and x, z. Then we have the x, y, y, z. I mean, we could go on and on with this. It's like y, z, x, z. Actually, wait. X, y, x, z, and there we go. So we have done it for two together. We could actually even do it for three, no? We could. Yeah. All three planes. Yeah, this was scary. So, okay, we can create a utility class that will handle matrix and vector matrix multiplication. Okay. They just created a class, okay, and then transform. You have ion dot x, ion dot y. Okay. What is in? Sorry, what is values? This dot values. Oh, okay. So all the matrix multiplications will happen here, and they want uh, hmm, math to radians. This is fine. Just a new double cos heading, sine heading. So you get the again. Okay, I think I will have to end the stream early today because I am quite tired and I need to wake up early tomorrow. This feels like such a lame excuse to end the stream, but yeah, I think I will have to. Also, I think before the next stream, I'll learn at least some of the Java basics. Not learn, but at least revise them because I don't remember basic stuff as well. Um, all I remember is system.out.println, and that's not enough clearly for this. So I think we'll continue this in a part two on the next weekend or maybe earlier. Although, nah, I think it's going to be the next weekend. Let's see. So ideally, now how does a roadmap look like, right? Let's go over that as well because this week we had our codec from scratch. Now we are doing the 3D render engine. We could create OpenGL in pure C++, or we could continue with Java and try to make something like Bash in Java, like a Bash script, build your own shell, which is like POSIX compliant. It interprets shell commands and runs external programs and stuff like that. So I will be sort of doing either this one, the Java one. I think I'll try to continue because I think August is almost over, and we need to up our level of being able to formulate or do stuff from scratch or by reading stuff, basically being able to build stuff without this sort of crutch. Because I mean, to be brutally honest, even now we are using this article, right? It basically has the code written. So if I just blindly copy the article, I will end up with the finished product and whatever bragging rights. But that is definitely not the long-term goal. So I think we will slowly be moving away from this sort of reading articles with code in them. We will look at more high-level concepts and then try to, uh, you know, uh, run our own inference. We'll probably go wrong a lot. We will need a lot of extra time for it, which is why I think the next one, Shell in Java, and this one, once these two are done, I think we'll do something more complex like making a database from scratch. Although I feel like that's in Golang, this has become like a phenomenon where everyone wants to, or everyone has basically seen Go databases written. But yeah, I think that is something which is next. Yeah, I think speaking more about roadmap, let's see how do we want to go about this, right? Because August is almost over. Then we have September, October, and November. These are the 3 months. And October, May, we will try to be capable enough to participate in the Hacktoberfest. Although, let's see, is there Hacktoberfest 2026? Do we have like any? No. Okay, we do have like the hack map for it. Okay, cool. So yeah, Hacktoberfest is going to start on 1st of October and end on October 31st, which is fair. Hacktoberfest 2025. That has ended, but they haven't announced anything yet. No global events. Let's see if this year they have a Hacktoberfest in Pune. We'll attend. I'll make a vlog about it and everything. But before that, uh, yeah, I think. Mm, okay, fine. So yeah, I mean, one of the goals is to participate in Hacktoberfest. I can't really show my screen right now because it contains some sensitive details at the moment. But yeah, okay, I think Hacktoberfest I can show. I'll just quickly switch tabs. Well, yeah, so this was what I was looking at. This is again last year's. So Hacktoberfest, if I do 2026, this is the article I was looking at, HackMap.io events or this thing. So we have this many days or whatever, I don't know what this is about, but yeah. So it's starting, it starts like always but this means that we will have to be ready at October 1 regardless, no? So what I'm trying to decide is what should be the pace of our projects. You know what we should do? I think I think the next week actually, we will do some Java. We'll like focus on coding in Java. Once that is done, we'll do like our big big project in Golang, which will be the database one. Once that is done, I think the database one itself will probably stretch into September. Like I'm expecting it to stretch up to the first week of September or even the second week. So yeah, okay, fine. So then I think so this week we started with the Java 3D engine, and then the next week we'll do the shell, the Bash terminal or this thing POSIX compliant shell in Java, and then we will start with the big project of database in Golang. I think this is still like the first week of August now, or what's today's date? Actually, it's Sunday, but oh no, it's the second week of August. Okay, so we have four more weekends for the Golang thing, the database. Okay, fine. I think we can still do it in this month, the Golang one, no? Yeah, yeah, because we have one and we have another Saturday, Sunday, Saturday, Sunday. We have three left. Actually, I can probably, yeah. Let's, I'll share my screen. Yeah, so this is what I was looking at. So we have this week, this is the next Saturday, Sunday. We have six in total. Oh, I will not be there. We won't have a live stream on 29th. I will be going out. So we have 30th left. Yo, hi. What's up? I was just planning future sessions. We did a 3D renderer in Java today, just the basic maths of it. But welcome to the live stream. Yeah, so we do have three weeks, roughly give or take. This is fine. Okay. So yeah, I think this week we did the basics of the 3D renderer. What we talked about, I'll just quickly recap it. We talked about the ordinate spaces on computer monitors, where the origin starts from here, and then we've how we've translated it to the middle of the screen. Do you know about CAD stuff? I do know some basic. I We had that in engineering in like the first starting of it, but I am not like the most credible or authoritative source for CAD related drawings, like Autodesk and stuff. I've really done limited of it. I have like one or two videos about it, about like orthogonal projections and stuff like that, but that's it. Yeah. Well, actually, now that you bring that up, this project is quite similar to an orthogonal projection. We are basically projecting like a 3D object onto a 2D space, which is like a good way to look at it, no? You're essentially bringing a 3D object and showing it as 2D, which is what we do in orthogonal projections. Nice. Anyways, so recapping this one, so we have basically drawing the first frame, then we'll make a bunch of 2D shapes. Basically, after translation, we'll create a vertex and the triangle using the vertexes. We will then create four triangles and add them to this vertex list, and then we'll transform them. So every time we basically move it, we'll transform the triangle. Wait, hold on. So I think that's exactly what is being done here. The length of these two and these two is changing, as well as the lines in the middle. So the transformation is being done on them, right? And this is what they're doing after adding color. So yeah, okay, so they are doing the depth buffer thing. So depth clipping is being done. We'll cover this in the next one. Okay, I think pretty much I've recapped everything. I think the link for this article is already available in the description, so this should be fine. Yep. Thanks for watching, everyone. This was a bit short of a live stream. I mean, we went a bit off topic with planning and stuff like that, and we didn't really code stuff as much because, again, this is Java, and I need to brush up my Java a bit. Also, just the fact that if we were to do this, we would just end up copying the entire code without understanding it. Yeah, so let's make sure we don't do that. We'll see you next week. We'll continue this project and then we'll start with another one, which is Shell in Java. Thanks for watching, or thanks for tuning in, I guess, because it's this is a live stream. Bye.